Good evening, students. In this video, we are going to discuss the combinational logic circuits used in digital system. Myself, Dr.Padmavathi, working as an assistant professor in General Engineering Department of R&D Engineering College. We start with the introduction about this combinational logic circuits. So, in digital system, your logic circuits that can be your logic circuits can be digital logic circuits that can be classified as two types. One is your combinational logic circuit and another one is your sequential logic circuit. So the basic difference between your combinational and sequential logic circuits are nothing but, so in combinational circuit, your output depends upon only your present input. So that is called your combinational system. So in your sequential system, your present output depends upon your present status of the memory element and present input. So in this unit number 2, we are going to discuss the what are the components in your combinational logic circuit, then how to construct the combinational circuit, and what are the working principle of the combinational logic circuit. Everything we will find it here. So the combinational logic circuit, already we know that your output depends upon only your present input alone, and the logic gate of the basic elements we are using in a combinational system. So the logic gates, the type of logic gates we are using in combinational systems are, one is your AND gate, OR gate, XOR gate, and then your NAND and NOR implementation also we are using in it. And what do you mean by your types of combinational circuits means? In general, your combinational circuit can be classified as an different types like adders, subtractors, magnitude comparators, multiplexers, demultiplexers, encoders, and decoders. And now we are going to discuss only the different types of combinational circuits. What's the working principle behind this, and what's the block diagram for this, and what is your applications of this combinational circuit we are going to discuss in this video. So what do you mean by adders means? So adders are nothing but your type of your combinational circuit used to add two binary numbers. Okay, so if you want to add only two binary numbers, then we are using only half adders. So only the half adder is sufficient for adding only the 2 bits of numbers. If you want to add the 2 bits of numbers, then we can use only the half adder. Then what do you mean by full adder means? If you want to add 3 bits at a time, then we will go for the full adders. Then what do you mean by your binary parallel adder means? So if you want to add the binary numbers in a parallel configuration, like if you want to add 83, if you want to add 83 plus 19, like that. So first what it do means, in the binary parallel adder, so that 83 and 19, that will be converted into binary representation of the bits, and then it will be added by using the binary addition rule. And what is the block diagram for this adders means? In adders, we have in general we are using the two outputs. One is your sum and another one is your carry. So this is your sum and this is your carry. So these are all the types of your output we are receiving from any type of adders. In any type of adders like half adder, full adder, and then binary parallel adder, we are using sum and we are receiving sum and carry as the output. And your input is depending upon which type of your adders we are using in it. Based on this one, your inputs that can be there varied. Then we should know that what is an applications and where we are using it. So this half adders and full adders, in general, we are using all the digital systems like your computers, calculators, and any digital measuring instruments. Okay, we are using this adders. Okay, and where we are using this full adders means in your digital processing devices like your arithmetic logic units, in your computer, we are using this adder. And next we will see to that subtractor. So what do you mean by subtractor and where we are using in it means, if you want to do the subtraction on a 2 bits, then we go for half subtractor. Then if you want to do the subtraction on a 3 bits, then we go for the full adder. Okay. Then now, what do you mean by this? What do you mean if you want to subtract the two numbers, then we go for half subtractor. If you want to subtract the three binary numbers, then we go for full subtractors. That is your 3-bit binary subtraction is nothing but your full subtraction and your 2-bit binary subtraction. So this is for 3 bits. Subtraction is carried out on a 3 bits, and here the subtraction is carried out on the 2 bits. So here it's based on your binary subtraction. So what is your output we are receiving in it from the half subtractor and full subtractor unit means in terms of difference and borrow, we are receiving it from the subtractors. And now what is the application of this? In order to reduce the force of audio or radio signals, we are using this half subtractor. And also, if you want to reduce the distortion in a communication system, then it can be used as an amplifier, and also it can be used in your arithmetic logic unit of a processor also. And if you want to know the exact address, that is, if you want to do the ascending and descending numbers of the array, then if you want to arrange the numbers in a particular sequence, then in that cases also we are using this subtractor. Then we go for magnitude comparator. So what do you mean by magnitude comparator means? Again, this is a kind of your combinational circuit. Here in this magnitude comparator, if you want to compare the two numbers, okay, like if you have A is a 50 and B is 90. So in that cases, if you want to add this two, if you want to compare these two numbers, which one is a greater or lesser, then which is equivalent to which number. So in that cases, we are using this magnitude comparator. So see to that in this magnitude comparator, we are receiving the output in the 3 combinations. That is A is greater than B, A is equivalent to B, and A is less than B. So these are all the 3 possible output combinations we are receiving in a magnitude comparator. Again, your magnitude comparator, where we are using in it means, so comparators are used in your central processing unit and in your microcontroller. Because in microcontroller, in a real-time application system also, whenever actually we are giving in all the digital systems, if you are using in a real-time applications, we are giving some conditions according to the Boolean law. Whether it is satisfied, then it is working. Whether your number of persons inside the room is greater than 50, then the particular AC that should be turned on means, then here we are using the comparators and the sequential circuits like counters and all, we are using in it to check the desired condition. So in that cases also, we are using this magnitude comparator. And also, what is the type of magnitude comparators means? That will be having a n-bit magnitude comparators are available. So n-bit means that is a 2-bit, 4-bit, okay? So these are all the different types of magnitude comparators available. And this magnitude comparator, it will construct using only the your AOI logic gate. By using AOI logic gate, we have to construct this magnitude comparator. And next one is your multiplexer. So what do you mean by multiplexer means? So these are all mainly used only in your communication system for transmitter and receiver side. So this multiplexer, in general, it's called as, that is your, we are using this in the data selection line. Okay. So multiplexer is, the another name for the multiplexer is a data selector. And what do you mean by demultiplexer means? It is called data distributor. So now we will discuss it. So what do you mean by multiplexer means? So generally it consists of 2 to the power n line in the output side, and at the output we are receiving only one output. So see to that we are receiving only one output at the output side. Okay, so depending upon this control line. That is very important. Okay. So here in your multiplexer, depending upon your control lines only, depending upon your selection of this, actually this is called control line or data selector switch. So depending upon this combination of a data selection switch only, your multiplexer input that will be received at the output side. So the combination, and also here your two to one types of multiplexers varied according to your input and your data line or selection line combination. So see to that here, your selection line combination is the 2 means, then it is called, that is your, if suppose your n input. Say for an example, if you have 2 power 3 inputs, that is 8 inputs. If you have 8 inputs, then your selection lines will be 3. That is 2 to the power n. Already we know that 2 to the power n is nothing but in this that is 2 to the power n to 1. So 2 to the power n to 1. So if n is a 1, then that is 2 to 1 multiplexer. That is in 2 to 1 multiplexer, we are using only one data selection line. So what do you mean by 4 to 1 multiplexer means? In that cases, we are using 2 data or selection lines. And 8 to 1 multiplexer means there we are using 3 data selection lines. So what is the major applications of this multiplexer means? In your transmitter side, if you want to transmit the audio signals and video signals through the one communication system, then we are using this multiplexer arrangement. Then what do you mean by demultiplexer means? So demultiplexer is the reverse operation of your multiplexer. That is, say for an example, if you want to convert your one input into the many outputs, like in your transmission system, like if you want to, if you have a television room, okay, or if you have the television channel office is there, so in that cases, we are using the different types of your signals. So that signals that will be transmitted to the different parts of the country and different parts through different parts of the world through the different output devices like LED, LED TV, or else your color television, or else your like your mobile phones, and then your through your radio signals, okay, and also through your laptop. So it will be communicated through the different types of output devices. Actually, the information is common that will be conveyed through the different types of your equipments in your receiver side. So in that cases, we are using this demultiplexer, that is 1 to many. Here also again we are using this data selection line. So data selection lines are nothing but here also depending upon your configuration of the data selection line combinations only, your input that will be conveyed to the different types of output channel. And next one is your encoder. Actually, the encoder and your demultiplexer and your multiplexer, everything seems to be a common, but the major difference, see to that, the major difference between your encoder, decoder, and then your multiplexer and demultiplexer is nothing but, so in your multiplexer and demultiplexer, we are using the selection line along with your input. But here see to that in your encoder, we are using only your input line. Okay, then we are receiving the output, that is without data selection switch. So that is called your encoder. So encoder again, where we are using this encoder means for transferring the data from one form to the another form. So in that case, we are using this encoder. So here see to that again 2 to the power n. Say for an example, if suppose your n value is a 3, so 8 to 3 encoder. Again here the encoder is constructed with the use of your logic gate, that is only OR gate, okay, OR gate or any other logic gate also we are using in it for construction of this encoder. And next one is your decoder. So what do you mean by this decoder means? So the reverse operation of your encoder, that is nothing but your decoder. So in the decoder type, we are using only your like your combinational circuits means here we are using only to convert our two inputs into the four outputs, like 2 to the power 2 or 2 to the power 3 in that case, like 3 to 8 or else 4 to 16. In that case, we are using this decoder system. Again, this is the one type of your combinational circuit, and also we are using the microprocessor memory system and then microprocessor instruction decoding and encoding options and all we are using in it, and also in your data encryption and decryption, data encryption also we are using this type of your digital systems. In general, how to construct this combinational circuit means the first step is we need to identify how many inputs and how many outputs are there in this system, in this combinational circuit. Like because if suppose your input is a n, then your possible input combinations are 2 to the power n. Say for an example, if suppose your n value is of 3, then your possible input combinations are 8 possible input combinations are there. So depending upon this 8 possible input combinations, according to the output expression, in which output expression we are receiving the we want to get the output. Like if you want to compare the two numbers, then we go for the magnitude comparator expression like that. So depending upon our desired output equation, your inputs and output numbers that can be first that can be counted, and next step is we need to go for our SOP terms, that is your design of a counters, because for design of counters or any combination circuit, you know that logic, okay? You need to identify that logic, and also you need to write down your output equation in terms of a sum and carry in case of your adders. In case of your subtractors means we are using that is your borrow and difference. So each and every term have a different equation. So that output equations that can be derived from the truth table using K-map simplification technique. So once the K-map is derived, your next step is we need to draw the logic diagram with the help of the logic gate. So these are all the overview about your combinational circuit. Thank you all.